I would like to introduce a very nice problem. So here is the following sum. Our goal, we are going to evaluate this sum as a convergent sum as n goes from 1 to infinity of 1 over n squared. Okay, I'm going to evaluate this one into different methods. So I'm going to start with the Fourier series method. So we have the general formula for the Fourier series. F of x equals a sub 0 over 2 plus the sum as n goes from 1 to infinity of a sub n of cosine n x plus the coefficient b sub n is multiplied by sine nx. Okay, we have the general formula for this coefficient a sub n and b sub n. So I have a sub n equals the integral 1 over pi, the integral as it goes from minus pi to the pi as a periodic function. For the periodic function, we have f of x is multiplied by cosine nx dx. For the coefficient b sub n, I will have the same thing. Instead to put cosine, I'm going to put sine. 1 over pi of integral as goes from minus pi to the pi, the lower bound and upper bound is multiplied by the function f of x is multiplied by the sine nx dx. Okay, to calculate this one, I'm going to use the Fourier series as a tool here. Okay, so the question, how to make the combination between this sum and this Fourier series formula. So I'm going to define a function. This function, I'm going to choose an even function which can make this coefficient be 0. Okay, I'm going to make this one 0. We are going to choose the even function because we know sine x is an odd function. Odd function is multiplied by even function is still odd function. So we know the integral of the odd function, if you have the bound minus pi to the pi, is going to 0. Okay, for example, let's take for example as a sine x as a periodic function. From this interval from 0 to pi, like this, and also we have this portion from this one to this one, like minus pi. This area equals to this area. If you calculate the integral over this area minus pi to the pi, which means this area plus this area, we know this area is negative. Okay, but we have equality in area here, so which means the negative plus this positive, it goes to 0, which means the odd function, this is odd function. So the integral of odd function is always given as 0 if you have if you are going to study this one on the interval minus pi to the pi, because the odd function is a symmetry to the origin. Okay, so whatever happens to the right side, it will be the same on the left hand side, that's why this one equals to 0. Okay, I'm going to get rid of this one and move forward. So let's set f of x equals x squared. Okay, we know this one is an even function. It is going to make this one equals to 0 is arithmetically. Okay, so this one make b sub n 0 because x squared is multiplied by sine nx is odd. Okay, I'm going to calculate e sub 0 over 2. E sub 0, I'm going simply to replace n with 0. Okay, so we'll have the following integral e sub 0, which equals 1 over pi from minus pi to the pi. F of x is x squared is multiplied by cosine 0, which is 1, which is dx. So since x squared is an even function, which means is enough to take only the interval from 0 to pi. Okay, so we'll have 2 times over pi of integral from 0 to pi of x squared dx. Okay, the primitive of this one is given as third x cubed. So this one will have 2 over pi of 1 over 3 x cubed as a primitive of x squared is evaluated from 0 to pi. Plug in pi into x cubed, I will get 2 over pi 1 over 3 pi cubed. By simplifying the 1 over the pi, I will get 2 over 3 pi square. Okay, now let's move on to calculate E sub n as a coefficient. Okay, so I will have E sub n equals 1 over pi of the integral from minus pi to the pi. By replacing f of x with x squared as an even function, we'll have x squared is multiplied by cosine nx dx. Since we know cosine is an even function, is multiplied by even function, that means the whole thing is an even function. So I can rewrite this one as 2 over pi of from 0 to pi of x squared cosine nx dx. So by choosing g of x equals x squared and h of x equals h prime of x equals cosine nx, like this. Okay, I will have E sub n equals 2 over pi. I'm going to put this one out of this. So for the primitive of this hx is the same as 1 over n sine nx. If you try to derivate this one, is taking you back to the cosine nx. Okay, so is multiplied by the original function, which is x squared, is evaluated from 0 to pi, minus the integral minus 1 over n, the integral of sine nx from 0 to pi, and the derivative function of x squared, which is 2x. I will put 2 here, x here, dx. Okay, before I calculating this integral, I'm going to evaluate this integral to see what's giving us. For this one equals 0, because we know sine of pi is 0 and sine of 0 is 0. So we'll have this term 2 pi is multiplied by this one, which is minus 4 over n pi is multiplied by this integral from 0 to pi of sine nx dx is multiplied by x. Okay, I'm going to do the same thing here by using the by part. So I'm going to switch this x squared, g of x equals x, and I'm going to switch this cosine to the sine nx. Okay, so we'll have the E sub n is multiplied by minus 4 over n pi as a coefficient. By part is giving us minus 1 over n, minus 1 over n cosine nx. For the is multiplied by x. Okay, is evaluated from 0 to pi minus the integral of minus with this minus becomes plus 1 over n of integral of cosine nx, the derivative function of x, which is 1 dx, is evaluated from 0 to pi. Okay, I'm going to simplify this one. This one is simply is giving us, I will get here minus 1 over n. We know cosine n pi, which is minus 1 to the n, okay, is multiplied by pi. This one becomes 0. By plugging 0 into x is giving you the whole thing 0. I'm going to simplify this one. I'm going to multiply this one by this one. Is giving us 4. This pi will be cancelled out with this pi. Okay. This n is multiplied by n is giving us n squared. This minus sign with this minus become plus. I will have 4 over n squared minus 1 to the n plus this term is multiplied by this term. Minus 4 over n squared pi, okay, like this, is multiplied by the integral from 0 to pi of cosine nx dx. Okay, the whole integral is taking us, is giving us 1 over n of sine nx is evaluated from 0 to pi, which equals 0. Okay, which means I will be left only with this term. Okay, E sub n equals 4 over n squared minus 1 to the n. Okay, now I have calculated the coefficient E sub n equals to this one. Now I'm going to plug all this information into the original function to see what's giving us. X squared equals E sub 0 over 2, which is this one. I'm going to divide this one by 2, is giving us pi squared over 3 plus the sum. E sub n will be replaced with this term, which is 4 over n squared is multiplied by minus 1 to the n is multiplied by cosine of nx. Okay, as n goes from 1 to plus infinity. This one equals 0. I'm going to replace this one with pi squared by replacing x with pi here. We'll get pi squared equals pi squared over 3 plus this sum as n goes from 1 to plus infinity of 4 over n squared is multiplied by minus 1 to the n. Cosine n, if I'm replacing cosine, plug in x with pi, cosine n pi is giving us minus 1 to the n. Okay, because cosine n pi is giving us minus 1 to the n. Okay, it's very known formula, it's very known value. Okay, to put this one together, this one is giving us minus 1 to the 2n, which equals 1. Okay, by taking 4 outside of this one, we'll get pi squared minus pi squared over 3, which equals this one equals 2 over 3 pi squared. We'll get 4 is multiplied by this sum as n goes from 1 to plus infinity, 1 over n squared. Okay, so by dividing both sides by number 4, this one equivalent, the sum as n goes from 1 to plus infinity of 1 over n squared equals 2 over 3, 1 over 4 pi squared, which is pi squared over 6. Okay, now I have evaluated this one by using the Fourier series. Let's move on to the next method where we can use the Taylor series combining with the Euler product. Okay, sine product. We have sine of x over x equal the product as n goes from 1 to plus infinity of 1 minus x squared over n squared pi squared. It's called Euler product. And also we know the sine of x equals x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7 over 7 factorial, and so on and so on. This is Taylor series or Maclaurin series. Okay, so I'm going to combine both two equations in order to get this one evaluated. Let's set f of x equals sine of x. Okay, we know 0 and pi minus pi, 2 pi and 3 pi minus 3 pi are the roots of sine x. Okay, you know sine x equals x is multiplied by 1 minus x over pi is multiplied by 1 plus x over pi is multiplied by 1 minus x over 2 pi is multiplied by 1 plus x over 2 pi, and so on and so forth. Okay, now if I'm going to tick this graph, we know the function of the sine like this. These are roots. We have 0, we have pi, we have 2 pi, we have minus pi and minus 2 pi are the roots. Okay, every two terms is the difference of two squares. I'm going to put this one together by multiplying this one by this one. Is giving us the reduced expression of sine x. I will get 1 minus x squared over 2 pi squared. For the second term, I will have 1 minus x squared over 2 pi quantity square, like this. And for the second term, I will have 1 minus x squared over 3 pi square, like this, and so on and so forth. Okay, I'm going to transfer this product into the sum, like this. If I'm going to multiply this one by 1, by 1, by 1, and so on and so forth, the result is given as number 1 as a first term. Okay, then I'm going to try to multiply number 1 by each of these terms. By this one, by number 1, this one will be multiplied by number 1, this one will be, and so on and so forth. This one, the result is given as minus x squared over pi squared plus x squared over 4 pi squared plus x squared over 9 pi squared, and so on and so forth. We don't care about other terms, so I'm going to stop here because I need only this one. Okay, here, this function, which is written on the form of the Taylor series, is the same function as written on the form of the Euler expression as a sign product. Okay, matching the terms together, I will get, for this term, for this one, I'm going to divide both sides by x, is given as sine of x over x, is given as 1 minus x squared over 3 factorial. We don't need other terms. The same function, which this one equals to this expression, 1 minus, going to take x squared as a common factor, so we'll have 1 minus 1 over pi squared is multiplied by 1 plus 1 over 2 squared plus 1 over 3 squared, and all the way down is multiplied, the whole thing is multiplied by x squared, and so on and so forth. Okay, this expression is the same as the sum of 1 over n squared as n goes from 1 to plus infinity. This one is multiplied by x squared. So by matching the term by term, we have x, this one is multiplied by x squared, as I have here. This one is multiplied by 1 over 3 factorial. I have minus sign here, minus sign here. Okay, so which means minus 1 over 3 factorial equals minus 1 over pi squared is multiplied by this sum of 1 over n squared as n goes from 1 to plus infinity. I'm going to simplify minus sign by minus sign here. We know 1 over 3 factorial is the same as 1 over 6. So I will have the sum by multiplying both sides by pi squared. I will get pi squared here over 3 factorial, which equals pi squared over 6. Okay, so I have done with this problem. If you are interested in watching this one, don't forget to support us with a like and subscribe. Thank you for watching. We will see you next video. Bye.